Today we're going to start velocity, position, acceleration. Those of you who are in or have had physics love this chapter, this part of this chapter. It's very apt. To me, this is the one chapter. I told you that yesterday. You don't know this yet. I just asked you to find the first derivative. That the first derivative of position happens to be velocity. And if you didn't believe that, think about the units. What would the units be if this is in feet and seconds? The position's in feet and the time's in seconds. What would the units be based on yesterday's work? Feet per second, which is a speed or a velocity. So the first derivative is velocity. What is that? A1. And the second derivative. Okay, let's talk about units on the second derivative. If this one is measured in feet per second, what would the second derivative be? Opposite, almost. Feet per second squared. Right? Feet per seconds, or feet per second squared, which is acceleration. So, velocity is the first derivative of position, the second derivative of position is acceleration. And so today we're going to learn what all we can find out about an object's movement based on these two things. We're going to spend a couple of days on that, but what all can we find out about an object based on the velocity? This is a graph of all three of those on the same grid. The position was that cubic, the velocity was the quadratic, and the acceleration is the line. Now, a couple of things you can tell from that. My function was increasing, then decreasing, then increasing, right? You remember all of those wonderful things we can tell from a graph. Well, we're going to learn today what that means for the position of the particle. And so, we have this problem. It's actually a mouse, but I'll get to the real problem later. The first question I have is, when is the object moving left, and when is the object moving right? Well, if I'm standing here, say centered at 0 or wherever I start, we'll find that out later, and I move to the right, that is a positive velocity, or positive change in direction. If I move to the left, that would be a negative change in direction. Like I'm going backwards. So, to find when an object is moving left or right, I'm going to look at the velocity, which you already have found. I think that's even factorable. Looks like that hits some pretty places in that. So let's try to factor it. Does 9 go into 162? Evenly? I think it does. What are the factors of 18 that add to give you 9? So, if I were drawing a sign chart, 3 and 6 would go on the sign chart. You see this from the graph. I have that velocity graph drawn there. So this is my velocity function, or S prime, whatever you want to call it. It is positive and negative and positive. So this is a sign chart we would have drawn earlier in our calculus proofs. What I know about it is if my velocity is positive, I'm moving to the right. So when am I moving to the right? Okay, since this is a real world problem, 0 to 3, why 0 to 3? We're probably not going to go back in time today. Maybe another day, but for today, probably not. So, right, so t being negative would make sense. So I'm moving to the right from 0 to 3 and from 6 to infinity, if it doesn't say otherwise. know that was kind of silly, but you will remember that. Do y'all remember that from last year? Yeah, so you'll remember one particularly the key. If you remember missing the on the wall. That sounds sad on video, doesn't it? So anyway, if velocity and acceleration work together, then your object speeds up. Velocity, acceleration work in opposite signs, then your object slows down. Now, this is a little tricky because if you just look at a graph, and let me go back for just a second, explain this a little more before we actually do it. A lot of people think acceleration tells you if you're speeding up or slowing down. But positive acceleration must be speeding up, and negative acceleration must be slowing down. But that's incorrect. A positive acceleration is an increase in velocity. But velocity could be negative, couldn't it? If your velocity is negative and it increases, you actually are slowing down because you're getting close to the x-axis. It's a smaller absolute value of velocity, which is a smaller speed. And that's really hard to think about. My calculus teacher in high school did not tell me the whole same sign thing. And so every time I had this question, I had to look at the velocity graph, do an absolute value of it to get a speed curve, and look to see when it was close to the x-axis, to see when it was slowing down. And that was a pretty difficult concept. So this is a big one. If you know this, it'll save you a lot of time and effort. So to find if I'm speeding up or slowing down, I'm always going to make two sign charts. I already have a velocity sign chart ready. But I'm also going to make an acceleration sign chart. And I'm going to compare the two. What was my acceleration function?
18t minus 81.
18t minus 81. So I'm going to make an acceleration sign chart at the 81 to both sides, divide by 18, and that is, what is that one? 4.5. I am going to be a little bit more careful than I normally would. I'm going to make sure I line that up in the correct place with the velocity sign chart. Is there a note I can let that way I can see what's happening. On the left of 4.5, I would get a negative acceleration. On the right of 4.5, I would get a positive acceleration. But remember, that doesn't mean I'm speeding up after 4.5, and it doesn't mean I'm slowing down before 4.5. So how do I find out speeding up and slowing down? I'm going to compare with the velocity sign chart. From 0 to 3, what do those have? Opposite signs. So I am slowing down, decreasing in my speed. Now again, my velocity.
Teachers and students, sorry for the interruption. We need the following students to report to the student union: Zeb Rush, Kim Roselle, Ashley Roselle, Bridget Milam, Walker Bedell, Austin Roses, Brittany Rathbun. Cancel that. Let's redo this list. Caleb Brasher, Maggie Anderson. Cancel that one also. Paul Cochran, Dakota Johnson, Chris DeWitt, DeWiggins, Faye Hobbs, Thomas Hicks, McKaylee Norman, Christian Palmer, Reagan Putman, Isaac Von Bargen, Zach Von Bargen, and Hannah Taylor need to report to the student union at this time.
Okay. So the object is slowing down from 0 to 3 because the velocity and acceleration have the same sign. Again, it's tempting to say just because the acceleration is negative, but it's because we had a positive velocity and it's decreasing, so it's getting closer to the x-axis, getting to be a smaller value. So velocity being 50 miles per hour is big velocity. We're getting closer to the x-axis. And so I want it to be slowing down, so I want the velocity to be getting closer to 0. So that's different. If I'm positive, getting closer to 0 is decreasing. But if I'm negative, getting closer to the x-axis is actually increasing. Does that make sense? Which is weird. So that's where we come to comparing sign charts. Exactly. So if I look at the what is velocity? They're both negative, so I am speeding up. So what's happening there is my velocity is negative, which means I'm going backwards, right? That's what negative velocity means. But my acceleration is also negative, which means my velocity is decreasing. I'm getting faster in the negative direction. Which is a little strange to think about. Again, comparing sign charts is much easier to think about. Okay, what about from 4.5 to 6? What about the signs? Slowing down, good.
Oh, I was looking at the next.
And then the next one, 6 to infinity. I am speeding up. Okay, one more time, I just want to show you how this kind of works. Now this is what you really need to know. Speed increases when velocity acceleration at the same sign, decreases when velocity acceleration at opposite signs. Remember our velocity curve looks like that, right? That's my velocity curve. My speed curve, those of you in physics will know this, but speed is the absolute value of velocity. Does that make sense to even those of you who aren't physics people? Velocity could be positive, could be negative. Speed is just how fast am I going, right? So the speed curve would look like this. The absolute value, everything's flipped up. So see how the speed is decreasing here? I'm getting slower here, but then I'm getting faster, and I'm getting slower, and then I'm getting faster, just like we pinpointed from our sign chart. So there are two ways to do this. One is the sign charts. I think that's my favorite way. Do y'all agree? The other way is to try to sketch something like this and do an absolute value of velocity to see where you're speeding up.
If you touch your tablet, they wouldn't grade sign charts, but since we're just trying to figure out the answer.
Now, your justification here, they won't grade the sign chart. This was just an answer, but if they did say justify, you would say because velocity acceleration is the same sign. And that they would grade that.
Or they have a different sign.
Right. So they won't actually look at your sign chart. This one didn't ask justification, but if it did, your justification would say velocity acceleration is the same sign. With the picture method, the justification is actually more difficult because you have to do some sort of explanation of how you know that the function is getting closer to the x-axis. To me, a little trickier to justify than just saying velocity acceleration is the same sign. Any questions on speeding up, slowing down? Draw a diagram of the motion from time 0 to time 8. What is the total distance the object traveled on this interval? So now I want to know everything. I want to know where did I go, what time did I get there, all of that information. So before I actually start drawing, I want to think for a second. I start somewhere, and my velocity at first was positive. Everyone agree? So from wherever I start, I walk to the right. Then after 3 seconds, what do? Stop, turn around, and go to the left, right? And then at 6 seconds, I stop, turn around, and go back to the right, and I go to the right from then on. Now I'm stopping at time 8, so of course we're not going to infinity, can't walk forever, so this has some influence. So I want to draw a diagram from time 0 to time 8. The first thing I want to know is where am I at time 0? If I want to know that, what do I look at? I want to know where am I? The position, the y-intercept of the position. Good. So I want to know at time 0, what is my position? So I'm going to find that really quick. And what is that?
Wait, are we still on the first?
Same problem. We're just finding lots of things about it. starting at time 0, and I'm going to the right. Well, how far to the right do I go?
What was it? 1 second.
Time 3. How far was that? How would you know?
3 6.
S of 3. Find the position at time 3. Now, why am I picking 3? Why didn't I pick 1 and 2? 3 is going to be where I turn around. Now, that's what I want to know. Now, how far did I go before I turned around? So I know I turned around at time 3 because I know the velocity changes signs there. So I'm going to plug in 3 into the position. So I'm going to calculator do that. I don't think it's a particularly pretty number.
202.5.
202.5. So I go all the way over to 202.5 units, feet, meters, I don't remember what problem was in, before I turn around. And this is when it asks you to draw a diagram, this is what I'm looking for. Something where you tell me how far you went. Some teachers will even have you put times in here, and you can do that, it might help you. As long as you get the distances, I don't really care, but
Thank you.
okay. How far do I go that way?
It's and then you put
Why 6?
oh good, you're still going away.
Right, all the way to 6 because I don't turn around again until 6. So for the diagram, do I have to think about acceleration at all? I just have to think about position at my critical point. Where am I when I turn around? So plug in 6. And what is S of 6?
162.
162 even. So I go all the way back to 162 before I turn around. And that is at t equals 6. You don't have to write that t equals 6 part, but I do want you to put a position of 162 there. I don't care if your diagram is to scale, you know what I mean? Like that, because I didn't draw that to scale. I don't care about that as long as you got the diagram telling me where you went when. The reason we're drawing these diagrams is to answer the next question, really. Okay, and then what's the last thing I need to know? Where I end. So at time 240. So I go all the way to 240. Okay, so I've gone to the right, turned around back, gone back to the right again. Here's the question that will come up. What's the total distance that I traveled? The most common answer that is not right is 240 units. 240 feet, 240. Why is that not how far I went?
Because you have everything.
I turned out, so tell a track runner they end where they started, right? Tell a track runner they didn't go anywhere, right? They went a mile or however, they just went in circles. So we definitely went somewhere. We went more than 240 meters or feet or whatever our units are in. So I want the total distance of the object traveled. How am I going to get that? Got to do some addition. Got to do 202.5 plus what? 40.5, but just to tell you where she got that number, that's in a different color so you see where we're getting it from. I've got to find the distance between 2.5 and 162. So that distance, and then plus one more distance, the distance from 240 to 162. So add all those up for me. That is my total distance traveled over the interval 0 to 8. So this is always going to take a little bit of work when we have to do total distance. 321. Well, there's 2 packets. So you'll see why. I mean, it's not really like today. 321 feet, meters, miles, I don't know, whatever we were in. I think this problem is a mouse. I think it might be inches or something. Any questions about how we did total distance? So, moral of the story on total distance travel. You do the starting position and the position at all of the critical values, the places where you turn around. And those are the positions that help you find total distance travel. The diagram will really help when you're doing that. Okay, this is where this problem came from, but I broke it up so that we can do bell ringer and stuff. See if there's anything I didn't answer. These are all different questions. Okay, so what is the initial position? We did answer that. Zero. What is the initial velocity? What's the velocity at time zero? 162. How is he getting that? Plug zero into the velocity. What is the initial acceleration? And so, if we want to put some units on these, do we have units yet? No. We'll make some up. Let's do inches. This would be inches per second. Or however fast that would be. And this would be inches per second. We already answered D, didn't we? Left and right, forwards, backwards. Forwards would be the right, backwards would be the left. We already answered acceleration being positive and negative. When is the velocity of the mouse increasing? I do want to go ahead and answer this compared with question G. Velocity increasing. That's just when acceleration is positive. So when was the acceleration positive? Look back at your sign. 4.5 to infinity. That is not the same as when are we speeding up. Velocity being positive just means you're moving to the right. Speeding up has to do with velocity and acceleration. We did answer these two questions already.
The 4.5 was the acceleration.
Oh, yes, it is.
Yes. That's still okay.
When is velocity increasing? So why would that be an acceleration question? If I'm asking you increasing or decreasing, isn't that the slope increasing or decreasing? I want to know slope of velocity. Slope of velocity, which is acceleration. We already answered speeding up and slowing down. I answered this, but it's good to hear the wording that you would hear in an AP. What is the displacement during the first 5 seconds? Does anyone in physics want to explain displacement? What is displacement? Displacement is your distance from where you started to where you ended, not taking into account turnarounds, not taking into account total distance. So the displacement during the first 5 seconds would be S of 5 minus S of 0. Just how far did I go in the first 5 seconds? So that's displacement. Total distance is very different because you have to do the diagram. Does that make sense? So displacement is just beginning minus ending distance position. Total distance, you have to do the diagram. So here's some concepts. You can either write them all down or print later. It's up to you. These will be on headlines. Concepts that you need to know, though, which kind of walks you through everything we just explained, just kind of a summary page. But we learned a lot just now, so there's a lot to kind of put together. If position is positive, the object is to the right of the origin. Or when we flip this and do objects that go up and down, it would be an object that is above the x-axis. So when position is positive, you are right of the origin or above the origin. If the position is negative, then you are left of the origin or below the origin. If velocity is positive, then the object is moving to the right or moving up if you're doing a projectile going up and down. If velocity is negative, then the object is moving left or down. If velocity equals 0, then the object is not moving. Now, it could have a velocity that's 0 for a long time, or it could be that I'm walking and I stop and turn around, right? That could be a velocity 0 for just a second. Or maybe I'm walking and I stop the time I shoot and then I get back up and keep going. So it doesn't mean it's necessarily a turnaround point, but it's a good, it's probably point. It could be a turnaround point. If A of t is positive, then the object is accelerating to the right and V of t is increasing. If A of t is negative, then V of t is decreasing. If V of t, yes, you can picture this. If V of t and A of t are the same sign, then the object is speeding up. If V of t and A of t are different signs, then the object is slowing down. Speed is the absolute value of velocity, and the average velocity is the average slope, which we could do as a slope between 2 points. Average velocity is not a derivative. It's, remember, anytime you read the word average slope, you think algebra 1. y2 minus y1 over x2 minus x1. Any questions so far? I think we'll do one more problem for today. One, up and down. So, you need to know, you need to memorize this equation. There are two different ones you can memorize in feet and meters. There is a more general equation on your calculus helper. If you will get your calculus helper out, look, show you what that equation is. It is the gravity equation. Right below the law of cosines on the page with a circle on it. See that? The gravity equation. The reason you need that is, what if we're not on the Earth? Right. These two numbers, those of you who've had a physics or maybe even from physical science, might know these two numbers come from the gravity constant. The gravity constant on Earth is negative 32 feet per second squared. It's the acceleration due to gravity. And so this is always half of that. You'll actually learn why it's half of that as we work through these problems. Because you're trying to calculus behind why that makes acceleration 32. You can probably see it already with a derivative. The gravity constant in meters on Earth is negative 9.8. So half of that is what goes there. The reason you need to know that is you could be given a problem that's on the moon, in which case your gravity constant would be different. They have to tell you what the gravity constant is if it's not one of these two. So keep that in mind. So it's half the gravity constant plus the initial velocity times time plus the initial position. Stands atop a cliff and throws his calculus book in the air with an initial velocity of 20 meters per second. Write a function for the height of the book. So throwing a book off a cliff. I remember this problem. Yeah. It's like that for real life. I think this problem up a long time ago. Write a function for the height of the book. And we are in meters, so which equation am I going to use? This second one. So negative 4.9 t squared plus what? Plus 20 t. Now, at this point in the problem, do I know how high he's standing? No. So, you got a couple of options you could read down and learn. at this point. So I'm going to call my initial position 0. What does that mean for the rest of the problem? If I call my initial position 0.
That'll be negative.
Good. Anything below the height of Chuck is going to be a negative value. Anything above the height of Chuck is going to be a positive value. If you happen to know how high it was from the beginning of the problem, you can put that in there, and then the ground would be 0, which works also. But don't get torn up if you can't put that in yet. Go ahead and just say, okay, we're starting at 0. We'll figure it out from there. How many seconds does it take for the book to return to Chuck's position on the cliff? So the first 3 questions here are algebra questions. They have nothing to do with calculus, but you will be expected to be able to answer them within calculus problems. So we need to make sure you can. How would you find that out?
Just graph it.
See when it equals 0? Right? Because everyone agrees. See when it equals 0? Because I want to know when the position is 0 back to Chuck's height.
Well, I think you just said that.
Yeah. So the equation equals 0. This is actually factorable. Back up T. And I can solve that. 20 divided by 4.9 is what I really want to know. What is 20 divided by 4.9?
4.082.
I know because it'd be negative 20 when you subtract it.
Oh, my bad.
Sorry.
I got confused. So it
Which
can't
one's
be 0.
Right. What is the 0 seconds? Why do you get that answer? That's right. He had the book at 0 at time 0. So it was there, but that's not what we want to know. We want to know how long did it take for it to get back there. So 4.082 seconds. For how many seconds is the book 15 meters or more above Chuck's position on the cliff? How do we do that? Okay, set it equal to 15. How would that be helpful? I want to know, really what I'm trying to solve is when is it greater than or equal to 15? When is the position greater than or equal to 15? This one, you could subtract 15 over, you could attempt to do some factoring, probably not going to work out nicely. So pick up your calculator and do that. Find out, what do I need to know? Which you already said it. I need to know that 2 times it equals 15, right? Because it's going to be the time between those 2 points. So, use your graphing screen, find intersections. Everyone know how to do that? Do I need to show you?
Or could you just move the number to the other side?
And then find m equals 0, that works too. Okay, I like that. To do the integration, just put negative 4.92 squared plus 20t in y1 and 15 in y2. Find those intersections. Which is easy either way, but usually do it. Does anyone need calculator help on how we're getting those?
Yeah, I'm lost. Did you do that?
And go to your graph and find when they intersect. You're probably going to need to move your window up to 15 to 20. Why? See that again. Oops. Because you want to see the top of that tablet. But you didn't actually see the top. That's okay. And so go to second trace. Number 5. Yeah. Find those intersections. and the line y equals 15. And those are 0.990 and. Is that what you said?
Yeah.
Sorry. So what is the time that it's above the 15? Subtract those, right? And what'd you get? Subtract. Because it was above that from here to here. So how long was it from 0.9 to 3.09? If the cliff top is 160 meters above the ground, how long does it take before the book hits the ground?
Now it's a lot.
Now I could go back and rework my whole problem, but do I want to do that? What would I want to do? You could go back and rework the whole problem with 160, which works. I like that. But how could I just leave my problem as it is?
Put it over on the other side.
Equal to negative 160. Don't I want to know when its height is negative 160? When I fall 160 feet below where I started. So it's up to you. You could go rework the problem because it's your problem. You could label the initial height whatever you wanted to. But I'm kind of lazy and would rather not go rework my whole problem. So I would just go, okay, negative 4.9 t squared plus 20t equals negative 160. You can solve that using the calculator. Intersections, right? Again. So my position is 0 to begin with. Above that would be positive. Below that would be negative. So I want to fall 160 feet below where I started. Can you calculate find these intersections too?
There's one in the negative and one in the positive.
And what are we going to do with the negative one?
Cross it.
Ignore it. Why are we going to ignore it?
Because it's not.
Because that's before he ever threw the book, right? So that doesn't make sense. So we're just going to pick the positive one. And what is the positive answer?
So you put those two in the calculator, but I multiply one by two.
By the intersections. Now I also want to point out / remind you about polysmalt at this point. I've shown you polysmalt. It's an app in your calculator. If you don't have it, just bring me your calculator sometime and I can give it to you. It will solve polynomials or quadratics, any polynomial for you. It is a little faster than the graphing screen. Sometimes the graphing screen is nice because you can see the picture, but it's a little more efficient. So if you ever want to see that polysmalt app, it's an app in your calculator. Most of them it's built in. If yours doesn't have it, bring it to me and download it. And when I download it, I'll show you how to use it. It's pretty efficient. What'd you get? What is the speed of the calculus book when it hits the ground? Now we've got calculus questions, right? We haven't touched calculus yet, but now we're in calculus. How am I going to do speed? The derivative. How is the derivative going to help me?
Velocity.
Velocity. Now is velocity and speed the same thing? No, but almost. What's the only difference? Speed's positive. So I will find the answer. If it's negative, I'll make it positive. It won't be negative because the book is falling. So I'm not going to have time to do this, but I would do B of 8.109. Why of 8.109? Because that's the time when it's the ground.